this going this year in February, and this is a good time of the year normally for me to get into things, and I hope that we can have quite a few of these sessions in the future. Just want to make sure that I have the control. Yep, it looks like it will work. Great. So the talk today is as advertised. I'm trying to stick to what I initially sent to Steve, but things happen, and I saw a bit of a discussion online yesterday in LinkedIn, and I thought, I'll have to add a slide about that, and I hope it integrates well. Jess, it was all about that, the note where you said you think you're sort of in the positive requirements space more than in the other ones. So I thought, where do I sit? So hopefully some of that sits in this talk as well. So we'll see how it goes. This talk is done in such a way that I'm hoping to say certain things in a certain way, and I'm hoping that people in the room will respond and so on. So if Steve can have a look at the room and sort of let people in to talk, that would be great, so I can focus on the presentation and not on the people in the room. But the idea is that we have discussions here and there as well, so I don't want to just be the lonely speaker on this. So the talk is titled Early V&V for Risk Mitigation in the V, the Systems Engineering V. And it was interesting for me to go back and dredge up all my drawings and different versions of the V that I've been working on since probably the late 1990s, 1999, thereabouts. And I realized that when I reread Forsberg and Moore's original paper, they never spoke about it as a static thing. And for some odd reason, I think we see it as some sort of static device that has some flow across it, but it isn't. And so therefore, some of my drawings will try to show that. But I think there's been great movement in the INCOSE handbook and also in some of the systems engineering handbooks out there to show this. So I think my first statement is that we are really good at building systems. I don't think there's a problem with that. But the question really is whether we are solving the right problems. And so this is what this is about today. Most of us in this room are quite comfortable with the concepts of verification, and we know how to check conformance, but risk often enters before we start building, right? And I think you can verify a system exactly to the specification, but if the problem definition was unstable, the risk remains. And so that part there, the problem definition that is unstable, is part of what I want to talk about today. So I want to look at the V as a risk lens, not just as some sort of interpretation of a life cycle, if that makes sense. So right, this is where the rubber hits the road. Is the second thing up there for everybody? Yep, looks like it.
Yeah, that's up.
So I thought I'd start with some sort of version of the classic V, and I specifically went back to a drawing I made in 2013 to try and explain certain things at Wintech here in New Zealand at the Waikato Institute of Technology while I was working there. And I was very clear in what I wrote around this drawing that the V is not just a life cycle a diagram, it's a structure for the discovery of risk. And as I said, the original authors did not present it as a static process, but iteration and continuous validation are embedded in that diagram. And I remember when I went to a conference in the UK, I think it was in 2000, when people first started adding the little V's inside the big V, and it caused quite an uproar because what does it mean? And it basically just showed how you could unpack it to show iteration, which is so important for us in problem solving. And I see my friend and colleague James Harrison is in the room. It's something that we constantly talk about, the iteration that is part of problem solving. So the issue is not the model, it is how we operationalize it all. So on the left-hand side, the way I like to look at it, and it might be different from how you see it, but I think the left-hand side is, for me, is interpretive. And that's where we see architectural and functional risk. And on the right-hand side, where we can explore it, and on the right-hand side is where we see the integration and emergent behavior and the risks that come with that. So from my perspective, trained as a physicist, the left-hand side is the analysis side, and the right-hand side is the synthesis side over time. And if your analysis is lacking, then the synthesis will be lacking. So that's how I try and see it. So the V can then be read as a structured way of surfacing uncertainty. So that's my claim for the day. Probably not a surprise to anybody, but I think it needs to be said. So what is verification, validation, accreditation? I'll keep it simple from my perspective. I think verification proves that we've built it right. Validation proves we built the right thing. And accreditation is often missed out in the discussions, but that's the part that decides whether the remaining risk is acceptable and who will carry it. Right? And so the verification is really conformance to spec. Validation is satisfaction of a stakeholder need in the context, and accreditation is acceptance of residual risk. So in many programs, these collapse into a late stage event. When do these actually occur in your program, validation, verification, and accreditation, and who owns the accreditation? I want us to think about that, but because we'll come back in the discussion session a bit later to that. Sorry, that one got stuck there for a while. Right. So let's talk about the V as a risk discovery. No, where did that go? Sorry. Things are going a bit fast here. The V as risk discovery. So what I did now was I put just what we've said before on the left-hand side, and I said it's interpretive risk, architectural risk, and assumption risk on this side. And the basically on the other side, we have the integration, emergent behavior, and governance. And so most risk is created on the left side and only discovered on the right-hand side. So the left side generates the interpretive risk. What did we mean? And this is often, I think, I stress this with people when I talk about requirements capture. I start with the user stories. So almost from a design thinking perspective, what are the user stories, the narratives, and how is that interpreted? And that is often where, people might get lazy and they just sign off because some of these things are quite big. Some of these infrastructure projects are huge, and so the interpretation is also a shifting and the expectations are shifting. The architectural risk is how did we structure it? And again, the architecture and the functionality often gets fixed very early on when we work on these things, because without fixing that, we have having some clear idea on it, we can't do the costing, right? So, and then that brings us to the assumption risk. What did we take for granted? And often in big infrastructure projects, there are certain things that are, where we have blind spots for it because of our past experiences in similar projects that might not be directly transferable to the next big one. For example, and I'm not going to use this example later in my talk as I planned, but the Dunedin Hospital rebuild is such a case. The old hospital is in one spot. The new one is in a spot just a few hundred meters down the road. But if you look at that part of the town, that used to be, part of the harbour swamp. Where the old hospital is, it was closer to drier ground and so on. So the initial idea was, well, there was a factory here before, so we take the factory down and then we build the 7-story building here, or how high we plan. But once they started taking the old building down and drilling and putting the big structure in, they realized that the substructure there is quite different from what the expectation was. And then things got stuck because people just assumed that certain things would be the same as what they saw just 100 meters up the road, I think. And when I started talking to people about this in preparation for this talk, I realized I'm asking the wrong question here. So, not even a coffee will unlock it. So on the right-hand side, there's, as I said, the integration risk. Once we see the thing starting to be built and what happens there, and then the governance acceptance, because that part there is often where we get stuck and where we are forced into certain things. So early V&V must reach leftwards into the problem framing, to my mind. Otherwise, the risk is only revealed during the integration. I want to talk about this as well, where I say requirements quality is equal to structural risk. And what I mean by that is that if we have poor quality, we will have high structural risk and vice versa. So if risk originates in the requirements, then early clarity is not the paperwork, it is economics. Early clarity is not paperwork, it is economics. Evidence across the domain show, for example, that more than half of defects originate in requirements from a raft of papers that I read over the past month. That became clear. Rework links strongly to requirements quality, and cost to fix escalates the later the discovery occurs. Now, I don't think any of this is new for any of us in this room, but the problem is we don't say this out loud, and we don't remind ourselves necessarily of this as we go. Uncertainty spans technical integration, operational readiness, governance decisions, stakeholder alignment, and in the case of some of the large infrastructure projects in countries, also comes with political coloring as well. So are we really validating our assumptions with the same rigor that we verify our builds? And that question there was fundamental for me in 2000 when I was asked to develop a group for simulation-based decision-making in support of an air defense, ground-based air defense system in South Africa. And we spent a fair amount of time and money, sometimes to the great dismay of the military client, on validating assumptions on the client side and working through possible iterations and different pathways that they might take as we all gather new insight. And it paid back handsomely, because once we started doing the simulation and they could see what was happening, they could make some really good decisions, and we didn't have a massive escalation of the cost of the project towards the end. And this brings us to the situation where, we find that, as I said there, 82% of rework is linked to requirements. And it was surprising, because I knew this, but it was good to read it again in a NASA paper, that on small projects, a strong systems engineering effort at the front end correlates with large cost differences. So if we don't do the work up front, on small projects, we could have an 18% overrun, and that's a small project. But on big things, it could be 90% plus, based on the size of projects, and it seems to be a nice pattern that you can follow. There's a 60% time and cost premium to be paid on projects with poor quality requirements. So I think that says it all, and brings us to this idea of the positive and negative requirements. So if we start with what the system, so I'm not taking sides on this. I want to be very clear, because you might get shot in the street if you do, right? And I'm definitely not going to question what Robert says in Australia, but I have a view on this. And I say that what the system must not do can often shape the architecture more than what it must do. So that's my position. hopefully we can talk a bit about that. We often emphasize capability. So what the system shall do, but constraints define the design space. And so that's where I go with my idea of positive being the capability and negative translating or mapping onto constraints, which is easier to manage then, because that falls in another part of the requirements framework. So the constraints define the design space, like environmental limits or safety thresholds or regulatory boundaries. Constraint uncertainty destabilizes architecture, to my mind, and risk often hides in the negative requirements. Again, that's my experience. So early validation effort should focus there if that is the way that we want to go. I hope we can have a few minutes to chat about that statement of mine. So perhaps before we go to the sort of case examples, are there any questions that people want to ask or statements that people want to make about this?
I think this is a really interesting way of a really interesting lens to use, looking at to look at shall do, shall not do.
Mm-hmm.
And I promise, Henk, that New Zealand law means I have no gun with which to shoot you in the street, even if we should significantly disagree. I also don't think we're very far apart. The idea of capability and constraint, I think those are certainly powerful in shaping architecture. And so I'm curious to hear more about what you have to say when it comes to specifically maybe couching that in the context of shall nots.
Yeah, cool. I will try and see if we can do that, because as I said, this slide came from the side after I read the comments on LinkedIn, and I thought, no, I have to say something because this is how I see it. So I'm careful because typically if I develop requirements, and my stuff is never in the shape and size of the two projects I'm going to talk about as case context for this talk, but I try to frame things within the shall state, and then when I look at the quality signifiers and so on, that's where I put the constraints. So I don't necessarily disagree with you there, Jess. In fact, I think I'm very close to what you're saying. Yeah, right. So the City Rail link. Now, obviously, I don't work on that project, and I haven't worked on it, and I know a lot of people in the room know about the project, might work on it, etc. So what I try to do was to say, what do I know about it from outside, and what have I heard, and what do I think as a result? So this is where I'm hoping that people can say, Henk, but you're totally clueless. It doesn't work like this. But my position on this is that complex integration, the assumptions are often the first thing that we build and the hardest thing to test. The assumptions are the first things that we build and the hardest thing to test. So if we look at the City Rail link, it integrates tunnels, quite a bit, stations, signaling, network conversions. And the structural questions to my mind are, where did we first verify multi-system integration? If we think about the V, where did we first verify the multi-system integration? Where did we then validate the operational peak assumptions? And where was the residual risk explicitly accredited? Would someone in the room try to perhaps talk to that for a minute or so? Because I only have 2 more slides to go, so we have time.
I know that there may be some folks online who are directly involved in the project who might not want to comment. I also have not been directly involved in the project, but but we have had insights from a number of folks over the years.
Mhm.
I think that I'm under the impression that the initial set of capabilities tied to economic benefit that would be made manifest by the City Rail Link, the scope of the City Rail Link project, that the translation of that then, that processes that were already in place were pretty good at that, scoping out a project based on capability that would need to be delivered. Where I think City Rail Link has done things differently is they then go the next level down and capture that in requirements that are then subject to verification. I think that I think it'll be really interesting after it's all wrapped up and done to see how the program actually did approach this multi-system integration, because I suspect it was perhaps underestimated, not out of not out of incompetence or anything, but simply because there was a degree of uncertainty, and whether that uncertainty that residual risk was explicitly accredited, I don't know. I know some folks who I would ask over a cup of coffee, but I don't know if any of them are on the line here today.
Yeah, I think it would be wonderful down the track, once, because the way I see this City Rail Link project, it is not a thing that starts and ends. It's one of those things that will have a life of its own, because it's not a simple. It is quite a complex sort of situation that we're dealing with in Auckland, and this is not just going to be a one-off type thing. There will be many lessons learned, and hopefully at a conference down the track, we can have people speculating on the questions on this that I have on the slide, that I thought about here. So, the multi-system integration, where was it first verified, or where did people validate the peak assumptions? And where were they assuming the residual risk would be accredited? Because it's not pointing the finger or blame shifting anything. It is trying to understand how we can do these things better, right? So yeah, I'm going to move to the second last slide, which is the ferry replacement. And I think the reason I look at this one and the rail link is that this is a very interesting system of systems program, where the integration is not really an event or a simple set of events. For me, when I started reading about it, it was almost like it was a bet on early decisions, right? And many of those were driven by outside forces, if you want. And we all know what this program is about. It's to replace one of the very important links between the North and South Island, and to upgrade it and so on. With the recent situation in the weather, for example, I walked into my local Woolies and the shelves were empty of a lot of stuff, and there was a big sign up saying, things couldn't pass across the strait. And I'm thinking, I said, they couldn't get anywhere to the South Island without passing through the strait. Very interesting. So, or cost effectively. So there's the weather exposure, there's national continuity, and so on. So it's a very important part. And when we listen to the political debates and shouting and so on, I was like, who decided what and who didn't have vision and so on. But I think it's quite, from a distance, it's a very simple thing. There has to be a port on the one side, a port on the other side, and vessels moving between them that is fit for purpose. And both ports need to be fit for purpose, and then the infrastructure linking them. And as you start to unpack that, you realize it is actually quite a complicated thing, not as simple as just buying a couple of ferries and making it work. So because the fact that it's a critical national transport link, it has all sorts of ramifications in terms of the supply sides on both sides and how things are managed. So what were the demand assumptions that were validated early? And how was the vessel port rail integration verified before the commissioning of some of the work? And who accredits the residual operational risks? So for my money, this is where the VVA intersects governance. So anybody want to perhaps raise a comment on this before I go to my last slide and my sort of summary of what I see the V doing? John?
I could perhaps comment a little bit on this, maybe a little bit on the City Rail Link side of things, and perhaps reinforce a comment that I made at the INCOSE New Zealand conference last year around the use of a concept of operations for developing this initial understanding of assumptions and giving something to validate against. And I think, City Rail Link has a concept of operations now. It was developed through the process of delivering, and there were similar reference documents developed early on, but I don't think there was a complete concept of operations developed very early in the picture. And similarly for IREX and the ferry replacement works, I'm not aware of a particularly comprehensive concept of operations that was developed early to provide anything as a sort of source of requirements for validation against. And there was I think in New Zealand generally we have a tendency to jump into the solution space and start writing detailed requirements because we give the task to experts who know what the solution's going to look like, and they're probably 90% accurate in knowing what the solution's going to look like. So that they're specifying, how long things need to be, what color they need to be, all the details, without really thinking about those early sort of operations, and therefore providing something written down that we can actually validate against. So. Yeah, that's my thoughts.
Absolutely. Thanks, John. I appreciate that, because I think one of the papers that I studied, I think was from 2024 INCOSE presentation or thereabouts that you made with, was it Steve, I think, in this regard as well. And you're absolutely right. I would imagine that for large projects like this, well, in fact, the concept of operations, to my mind, is such an important thing to have some clarity about and agreement on. Even for small projects where we, in design thinking, where we go, this is the user story, this is the pain points, this is how we're going to relieve it. That's a concept of operation in a very limited form. And but without that, you seldom get to deliver something that is fit for purpose, right? So yeah, absolutely. I can really just agree with what you're saying there. So on to the last slide, while we have the last bits of our sandwiches, I guess. So what I did here was to say, okay, if I now look at the V and I summarize what I've been talking about here, then I'm basically saying if the validation waits for the right side of the V, then the risk has already been embedded on the left. So 3 questions that I really have for the room is, when you look on the left-hand side, I've just summarized what happens there. So we have almost like a confidence gate before we move into the detailed design. And it links back to what John said. If you have a clear concept of operations, or a good set of operational concepts that you can start with in terms of the systems concept and the requirement there, then by the time that you get to around this area, you have some clear ideas of where the risks are. And so you have a confidence gate almost that you shouldn't pass until certain things are really discovered, like the assumption stabilities on assumptions, the constraints that are clarified, interface criticalities, geological and other environmental drivers, etc. And in New Zealand, also cultural aspects of big projects. So all of those things tend to sit on this side here. And there's a confidence gate that I think we often rush through on the way to start to build, while, we should actually still be spending time here to make sure that this cost of late corrections doesn't spiral out of control. And obviously this is, where my hobby horse, the simulation-based systems engineering, sits as well. So this allows us to do a heap of things to ensure that this part here works really well and that we manage that. So the questions are on the screen there. I'm going to leave it up there to say, if we want to talk a bit more about this whole talk and so on. I think today the questions that I thought would be important and that I tried to address through some of the experiences were those. So where is the first meaningful validation checkpoint? We talked a bit about that. Who owns the accreditation of residual risk, and what left side activity would change if validation thinking starts earlier? So, because I'm saying that you can verify a system exactly to the spec, but if you never validated the problem that it solves, the risk will remain. That's me. Thanks.
Thanks so much, Henk. Really, really interesting topic, and yeah, a great start to the 2026 list of conversations we'll have throughout the year. Sorry, Jess, I'm gonna hijack the first question, just as is my right. But no, it's probably just a few kind of observations as I've kind of gone along here, where I'm thinking about the first meaningful validation of the program. A part of me actually thinks that, well, if you're only starting the validation when the program's kicked off, we're already behind. The validation should be right at the business case level and understanding those problems, because obviously we're only going to be as solid as the foundations that we build on. And I feel that that's the real challenge we have within systems engineering. And I know this has been a big focus on a lot of people, for a lot of people recently as well. Actually, how do we get this sort of thinking and validation activity before the project kicks off and actually make sure that the business case is validated in the right space as well? And sorry, it's a bit of a diatribe, but yeah, I get frustrated when people say, well, validation is in the top right-hand side of the V. I'm like, well, no, that's the latest point you can ever validate a system, because that's when you find out your risks. No, you don't find out your risks, you find out your issues. And so you should be validating as early on as you possibly can. And so, yeah, I completely agree with that. And things like ConOps, I think, are incredibly important. Even things like frameworks. If you use architectural frameworks and actually try to understand the viewpoints of different stakeholders, whether they're users, whether it's for logistics, whether it's for maintenance, whatever it is, at least then it tries to put people in the mindset of, well, what will these people be, how will they be interacting with the system, and who do we need to talk to make sure that those things are valid? Because I feel like the biggest challenge we have on the left-hand side is, I think, the biggest risks we have are the unknown unknowns. And when we figure out we've got a known unknown, I feel like that turns into an assumption, and then that assumption should be validated and then turn into a known, which then should turn into a constraint or a requirement in its own right. And so validation should happen all over the place. And I think we have tools to highlight the risks where we think we know something. And if we think we know something, we need to validate it. But the real challenge is, well, what are the real unknown unknowns? And I think things like frameworks and all of that sort of stuff, and obviously talking to previous kind of projects and similar programs, I think is an incredibly valid point as well. So pretty less of a question, but I do have a question actually, sorry, which is around just this model around the V's and the V's within the V's within the V's. And I'm looking at it and I'm actually thinking, well, the V model is great. If you kind of know what the end state looks like, it's relatively stable in terms of, the scope and the interfaces and all of that sort of good stuff. But obviously it's just one lifecycle model. And so we have other lifecycle models. And I'm looking at this and going, well, actually this could almost be seen as another representation of, say, like the incremental kind of spiral model, because we're doing those increments within the V itself. And I just wanted to, I guess kind of air that with you, Henk, and check whether you agree or whether you actually see it as a slightly different approach.
Agree with you on that. When I first saw the stacked V's and so on, and I've sort of kept this one because some of the things that started coming out in the after 2010 and so on were so so difficult to unpick and see what was happening. So I kept it to the simplest one that I think is still representing iterative sort of approaches. But the first time I saw this, I thought, oh, this makes complete sense from a spiral development perspective, right? And from a software development perspective, there's no surprise here. Because if you look at it from a spiral perspective, you could connect one layer of V's with another layer, and then another layer with another layer, etc. And there's a spiral actually spiraling through the V and the different little small V's, isn't it? And that makes sense from a software development perspective. And why is it that we're comfortable with it there? I guess the only reason I can think is that people assume that software development is something where you can quickly erase stuff and rebuild. Not so much, right? It is as complex and complicated these days as it is to build a tower. So I guess absolutely. And in a funny way, if you stand back from all of this and you look at how people go about problem solving and doing the early parts of research into the problem spaces, like action-based research, where they explore things, there's an iterative cycle there, but on the inside of it, for those from a software perspective, there's also a recursive thinking profile where we reconsider what we knew. So that's the assumption checking and then updating our assumptions. And unless we do that, we will go through a spiral based on decisions that we might have made already up front, almost full well knowing that we're going to screw it up at the end, right? We're going to get something that is almost there, but not really. And that to me is often under the pressure of finances, the project managers, we tend to get stuck in that thing because we just have to move on, because otherwise this thing will be cancelled or something weird comes along, right? So I fully agree. It's a long answer to basically just confirm how happy I am to hear that.
No, thanks, Henk. It was a long-winded way to ask the question in the first place, so it's all good. Jess, I appreciate I cut you up there. You had your hand up. Do you have a question?
I cede my time to Russell.
Thanks, Jess. Russell, over to you.
Cool. Can you hear me?
Yep.
Cool. Just wanted to comment on the trade-off between a spiral versus a V model.
Yeah.
Excuse me. I think one of the considerations there is where are the risks being generated in the delivery process, because that will define where what's an appropriate delivery model to apply to the whatever it is that you're doing. So I work in NZTA. We do a lot of big infrastructure projects, and the thing that stands out for me is that a lot of the heavy duty risks, like literally pouring concrete in the wrong place. Once you've poured it, that's it. It's not moving. Those are real front-end risks. So something like a view model is very applicable to that, because you want to manage those risks very early. Otherwise, it's a very costly exercise. Versus something that's more in the technology domain, where a spiral model might be more appropriate, because the end result's not fixed in concrete, if I can use that term, and you can come back and change things. And a more iterative approach might be a better delivery model for that, because you can get early benefits. You can get something out there, like was just said. Might not be perfect, but you can come back and iterate on that and make it better. But it gives you early benefit. But you know that you can manage the risks downstream, if that makes sense. So I just wanted to comment on it. I think a lot of it depends on what it is you're dealing with and where the risks lie in the delivery life cycle of the project. That's it for me. Thanks.
I agree fully, Russell. That's an important comment, and a great example. If you've poured the concrete, it sits there. Yeah, it's not. And as I say, in software, you at least feel like you have some way of spiraling through revisits and so on. I think that where the spiral type approach really could be beneficial is when we say in the upfront part, spiraling through some using concepts of operation to understand what it is that we need to check fully. And this is why we have model-based system engineering and modeling approaches, etc., is to try and discover these things. It might not solve all of it, but it shifts the risk to another point where you can say, well, we did what we could. Look, everybody saw this and not that. So yeah, absolutely. Thanks for that one, Russell.
Thanks, Henk. Back to you,
Cheers.
Jess.
Thank you. Henk, this is great. I'm really enjoying this. I wanted to talk to the bottom question, what left-sided activity would you change if validation thinking started earlier? So in a prior life, I did system security engineering for a US defense program. And up until we had to respond to to a change in policy where how much security risk was acceptable used to just be a line, and all you had to do is show you met the line, and if you're above the line you go, and if you're below the line you don't. And there was I was working in the transition period where it was switching from that sort of framework to one that was more around total risk. Like, yes, there is a risk that this technology could be abused or misused or whatever if it's fielded in an insecure state, but how does that stack up against the risk to warfighters for not having that capability in the first place? And so I was very deeply involved in some of the conversations around, yes, but if we can't get this thing out the door, yes, I understand that, but if we can't get this thing out the door, bad things are going to happen. And so that was a really powerful motivator to step back and think about not just my part of the system looked an awful lot like this, but this was just part of it. And if you only looked at it from this perspective, if you only took this view, then yeah, that was a catastrophic risk we couldn't tolerate. But if you step back and you put that in the context of the larger operations and other contingency plans, there really was a risk transfer activity. So I was happy. What I did as part of the team at that time was to help to develop a way of characterizing and analyzing security risk so that those kinds of decisions could be made. How much risk is acceptable is ultimately determined not just by the project manager, but ultimately by the user to whom that system is transferred. And so one of the things that we changed we changed the way of working to build in, firstly, I had the definitions of validation and verification printed in large print and stuck up on the wall so that while the technical teams were looking at designs, they could put their glasses on and look at this. Are we looking to see if this thing satisfies the requirements that it satisfies its specification, versus are we looking at this thing to determine whether the level of residual risk is acceptable? And that instead of doing that at penetration testing at the very end when you had a prototype that you could play around with, we did that at system requirements review. We did a validation activity at system requirements review. And some project managers and contractors who were doing that design complained that we were being, that we didn't need this level of oversight that early. But it didn't take very long moving through this process for them to for everybody to collectively understand that now this is a different way of looking at it, a different way of working with risk. And yes, this program is a whole bunch of money being thrown at the development of a widget, but ultimately that widget serves a purpose. And if we can and should take into consideration that purpose and end user context when we talk about that, and thus validation, not just does it meet its requirements, but is it suitable for its intended use, and what caveats do we need to make on that? That was all part of it. So I would love to see more conversations around that recognition of transference of risk in some of the sort of outside of the defense and aerospace industries that we work in. So safety critical, anything that's safety critical usually has a pretty good, there's good precedents for doing that kind of holistic analysis. But outside of that, I think that there's a tendency to remain focused only on the project, and to remain focused only on what the bills, what the scope of the thing that I'm working on today, and to lose and ultimately to lose sight of the fact that unless you're developing it for yourself, you're developing it on behalf of others who will be your users, and they need to have some participation in this risk understanding and transference process as well. So anyway, like I said,
I love what you're saying, because and your question or your position to say, we need to look at it outside of the classic places where we really have to make these risk trade-offs, right? In the military, for example, aerospace and so on, because we clearly think about the humans in the loop there. And it was very interesting. I worked on a project a while back on the development of a new smelter. And for some interesting materials, and the question never came up, about what the smelter should do. We knew that functionality was clear, but it hinged on one of the biggest risk assessment matrices I've ever worked with. Because everybody needed to know what our assumptions were and what the impacts would be on the residual risk. And the project was eventually parked because of that risk assessment. So there was a prototype built to a certain point, but it didn't go beyond that because we couldn't bring enough evidence beyond a certain point. And the company was quite happy that they've done the right thing. So there we go. But it wasn't what the program team wanted, obviously, but we all looked at it and we said, well, we've done a really good job here, and so this is it. We can't solve some of these things. We can't manage those risks, and we can't transfer them beyond the point that we have at present. So we are stuck on that one. And those were not imagined risks. We could clearly see how they would eventuate. So yeah. But for that, we had clear concepts of operation of the whole system in which it was incorporated.
If I could just add one more thing before I cede time back to Russell. I think that project managers and program managers are really good at, they're really good at managing risk, but the kinds of risks that they're incentivized to think about are not always the kinds of risks that the end user needs to be aware of accepting. And that disconnect, that I think, I am of the opinion that one of the superpowers of systems engineers is, even if we're in a role that's project focused, it's really hard for us to only operate with blinders on to the scope of the project. And we tend to work best and think best when we can think about and talk about what came before and what comes after, because that shapes what we do now and how we understand what we do now and how we set ourselves up for what we do next. And so I want to make good friends with, I know the Project Management Institute and the International Council on Systems Engineering have organizationally agreed that they should be closer together, and they've got more, that there's more overlap. But I would love to see more conversation about technical risk and the transference of risk to end users at the end of a project, as part of risk management discussion, not just is it late or expensive. I'll stop there.
Absolutely, absolutely. And the nice thing is that I was lucky enough on that team that the program manager was a systems engineer. So the thing blended really nicely. There was the discussions focused on the real stuff all the time, and so although we were disappointed, we were not disappointed in the technical side of things. We were just saying, well, it's not the time for this right now. Russell.
Cool. Yeah, over to Russell.
Cool. Thank you for that. I think Jess may have got there before me, but just wanted to, just from experience, I think, and certainly on the technology projects I've worked on, it's not just following through with what Jess was saying. Most of the project managers manage the risk in the context of the project and the delivery of the project, but they don't look beyond the delivery endpoint into what the business change impact of that project is going to be. And from my experience, that is usually the thing that kills a project off. I mean, you can deliver an efficient project on time and to budget, but it's still a lemon when you put it into an operations environment because you haven't accounted for the business change impact. I think a lot of project managers are not incentivized, rightly so. Their job is to deliver the project, not to manage the business risks around the organization. But that part, for me, often gets left off. And just following up on a previous statement, when you start to do iterative development, that's something that you need to take into consideration when you're managing the risks, because you might change something that it might be a minor technology tweak or a minor upgrade, but it may impact a workflow quite significantly or create a data quality issue or something like that, which could very quickly damage a project. And I've seen quite a few projects fail badly because they haven't accounted for the end user and the business change impact of what's being delivered. So I think I'm lining up with what Jeff said, bringing the user into that space to make sure your things can be fit for purpose. Cool. I'll hand back now. Thank you.
Thanks, Russell. Absolutely.
Cool. Thanks, Russell. I think we've got time just for one last question. So over to Karina.
Yeah, thanks. I'm looking at the clock and realize this might be a bigger can of worms than we really have time for. But I wanted to thank you for your example about the hospital being, shifted to a new site. I just started working with a new group just this week, and I'm learning all about it. And one of the risk lowering techniques that they have is that they're building essentially two instruments at the same time. And I'm the systems engineer for one of them. And the other one is they're building it essentially as a working prototype for this next one. And one of the reasons I was brought on board is that they're building it for a much larger group who essentially said at the preliminary design review, you guys need better systems engineering. Can you hire a systems engineer, please? So I find myself being brought in 1 year before the final design review and I think their assumption is, hey, you'll help us with all of our paperwork and all of our requirements and meet all of these reporting things. And so I have like 5 different things going on in my head right now. But yeah, sort of how do I adequately sort of say, okay, great, you're building this first instrument. What assumptions are you making by building that instrument that you're not then addressing with the second instrument? Is that sort of I don't know what as I said, I have 5 different things in my head and I'm looking at the clock, but yeah, thank you for having my brain go down this route.
Well, that's fantastic news, Karina. I think, and I don't envy you, coming in late stage on a project like the one that you might be talking about. So I think for me the main thing is to look on the left hand side of that last diagram in the talk, where we said where's our confidence gate, and how much can we do on that left hand side to consider the things like the assumption stabilities or the constraint clarity and the interface criticalities and things like that. And for each big project, there will be a set of things there that is really relevant. it might be that it's not so much geological or environmental drivers, it might be energy drivers, whatever it might be. That becomes a real issue. And so it's trying to surface those, I guess, in terms of that first confidence gate, so that before you get too far down the build components bit, you've validated things. Now, if they're already in the almost build components phase, it's a question of trying to see how much of it you can model in ways that we have many tools for. So to see where the risks might emerge down the track, because that's the only other way that I see. But there's such a great community in this room that I think perhaps it's the sort of thing where we could in future really think about it. Jess and Steve there, where we say, have a session where people bring ideas to the table and say, how would the rest of this group address this? Just like you've asked, Karina, because we can then share our experiences, and that might give you some insight that is really useful at that time. But that's all I can offer at present. I haven't been involved in the deep side of this, luckily, in New Zealand recently. So
no, it's,
I support that.
Yeah,
I support having some roundtable discussion things from time to time. That would be rad.
Yeah, definitely. I think it's a good great kind of segue to wrap up, actually, in terms of, well, how do we kind of continue conversations, make sure that we as a community, without sharing too many secrets, help each other. But I appreciate we are over time, and probably sandwiches are eaten and afternoon meetings are probably kicking off. So Henk, just want to thank you again. It was a really, really interesting and eye-opening conversation and presentation. So thank you so much for taking the time to pull it together and to host this discussion as well. And thanks to everyone for dialing in. Great to have us all back in 2026, and let's hope we keep this momentum up and this conversation going throughout the year. So looking forward to all the future ones to come. Thanks again.
Thank you very much. Thanks guys, for everybody being here today. It was fun. Thanks.
Thanks so much.
For sure.
Thank you.